How can electric potential energy be negative? If we make an effort to draw two charges closer, they will repel only when they are alike. So that work done is against the electric field. When the point charges are brought closer and closer, the repulsion increases. When the electric charges of opposite polarity are in the vicinity of one another, there will be an attraction between the charges. Positive work is done on the charges. So the system of charges possesses positive electric potential energy. Suppose the system has only like charges, then the charges are repelled from one another because work done on the charge is against the applied electric field. So the electric potential energy becomes negative. The electric potential energy of a given system is given by the expression where UE is the electric potential energy, Q1 and Q2 are the point charges, R is the separation between the charges. The work is done on the point charges is opposite to the electric field, and the force which brings the point charges from the reference point to the finite position given as. From the above facts, it is clear that if a system possesses an excess of like charges, the system acquires negative potential energy. The fact of negative potential energy can be explained in terms of the following consequences, which clears the confusion of negative signs in the integral. Work done by the electric field. An electric field possesses radial force, which is always pointed outwards while the charge displaces inward. Hence the electric field specified in the integral has a negative sign. Work done on the particle. If the force applied to the charge is equal to the electric field, the radial force acts inward, and the charge also displaces inwards. At that instance, the integral will possess a positive sign. Can you have a negative electric potential? One can have negative electric potential when there is an excess of like charges. Consider a system of charges. If the system possesses more electrons, some of the electrons do not contribute to the conduction because they become free electrons. If some force is applied to this free electron brought them closer, they get repelled. Due to this repulsion, the potential energy stored in the electrons becomes negative as the work is done opposite to the applied force, leading the electric potential to be negative. When is electric potential positive? A charge acquires positive potential when charges of the same kind are placed together. Since like charges always repel, it needs an external force to bring them closer. The external force requires some potential energy to work on the particles. The work done is negative as the behavior of the particle is against the applied Coulomb force. Hence the potential becomes positive. We can say that the more the number of positive charges, the more the electric potential becomes positive, as the positive charge tends to move towards low potential energy. When is electric potential negative? Electric potential becomes negative when the charge of opposite polarity is kept together. As there is an attraction between the oppositely charged particles, they do not require any external force holding them together. In the absence of external force, the work done becomes positive. The Coulomb force and the work done are in the same direction, hence, the charges move towards the negative potential. Commonly, it is said that the system acquires negative potential with a more negative charge, as the negative charge tends to move towards high potential energy. Frequently asked questions. Does negative potential energy indicate the negative charge? Negative potential energy means the charge acquired less energy than the Coulomb at the reference point. The negative potential energy does not indicate the negative charge. In fact, the negative potential energy is possessed due to both positive and negative charges. Does the negative charge decrease the potential? The negative charge directly corresponds to the magnitude of the energy and force between the charges. When the negative charge is increased in a system with positive charges, the magnitude of the potential energy increases, but the force between the charges become more attractive, leading to a decrease in the potential. Do electric potential energy and electric potential are same? Electric potential and electric potential energy are the two distinct quantities which depending one over the other. Electric potential energy is the specific amount of energy required to push a charge in an electric field, while the electric potential is the tendency of a charge to do work by the influence of electric field. But both electric potential and electric potential energy correspond to each other. In which component does the electric potential energy is stored? A capacitor stores the electric potential energy, which is ready to supply the charges when it is required. A capacitor is an electric component that can store the charges and supply the charges to all other components for electric conduction. Does the electric potential energy depend on the direction? Electric potential energy is a scalar quantity which has magnitude and independent of direction. The electric potential energy specifies the work done on the charge. But work is the scalar quantity given by the dot product of force times the displacement. Hence, the electric potential energy is independent of direction, but the charge matter as position and nature in the electric potential energy. Does the distance between the charges affect the electric potential energy? The potential energy tends to increase when the separation between the charges is more. Suppose if the two charges of the same sign are brought together, obviously, they repel. Then it would be best if you exerted more energy to get them closer. As they go far away, their potential energy also increases, moving towards another charge. Why does electric potential decrease when the potential energy is high? A charge has the ability to increase its potential energy when it tends to move against the normal force. As the charge moves away from the electric field, the potential energy stored in the charge comes into action by exerting some force on the charge to move towards the field direction. Once the charge begins to move away from the electric field, it cannot move back. As a result, the potential decreases. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.